Are robots coming for your job? I mean, it's pretty much the ultimate question of our modern era, isn't it? Whether you're just scrolling through the morning news, sitting in a board meeting, or honestly just chatting with friends over dinner, there is this palpable anxiety in the air about the future of work and what it really means for all of us. But, before we can understand where we're going, we really need to understand the vehicle that's taking us there.
So welcome to The Explainer. Today, we are demystifying automation together. We're going to break down what it actually is, uncover its surprisingly deep roots, and look at the hard data to see exactly where it's taking our jobs, our economy, and our society as a whole. We have a lot of really fascinating ground to cover, so let's just jump right in.
Section 1. What is automation? Defining the machine.
Okay, so before we even touch on stuff like artificial intelligence or self-driving cars, we need a rock-solid baseline. Pulling directly from IBM and Wikipedia, automation is the application of technology, programs, or robotics to achieve outcomes with minimal human intervention by predetermining decision criteria. That's a bit of a mouthful, I know, but the crucial point here is that automation isn't just about literal robots with metal arms. At its core, it's simply about reducing human input. You set the rules, you define the parameters in advance, and the system just executes the task. It's really that simple, and yet it is profoundly transformative.
Section 2. A surprisingly ancient history. Older than you think.
We always tend to think of automation as this super modern concept, right? Like it was born in some Silicon Valley garage. But no way. These roots actually go back millennia. Starting way back in 270 BC with a guy named Ctesibius in Ptolemaic Egypt. He designed a float regulator for a water clock, which is basically the earliest known feedback-controlled mechanism. Wild, right? Fast forward to 1785, and Oliver Evans develops a completely automated industrial flour mill. Now, it actually wasn't until 1947 that Ford formally established an automation department, which is really what popularized the term itself. And by 1959, Texaco's Port Arthur refinery became the very first chemical plant to use digital control. So yeah, this is a journey of thousands of years.
What's really fascinating here is the massive contrast in the tech itself, even though the ultimate goal was exactly the same. Ancient automation relied entirely on physical mechanics. We're talking things like water floats and centrifugal governors physically adjusting millstones. But 20th century automation completely shifted that paradigm. It relied on relay logic, solid-state digital modules, and eventually early computers. The fundamental objective, minimizing human intervention, has literally not changed in thousands of years, but the driving force shifted entirely out of the physical realm and into the electrical and digital. Section 3. Modern machines and intelligent tech. The evolution of IT and AI.
Bring this right up to the present day, we can clearly see how automation scales using IBM's three-tiered framework. Step 1 is basic automation. Think of digitizing manual, super routine tasks. Stuff like automatically forwarding emails or just sending out invoices. Step 2 scales that up to process automation, which manages complex multi-step workflows across a bunch of different systems, basically bringing uniformity to entire business operations. And then we reach Step 3, intelligent automation. This is where the real magic happens. This combines artificial intelligence with robotic process automation to actually streamline complex decision-making.
So what does this actually look like in the real world? Well, it looks like highly specific technical applications completely transforming enterprise efficiency. Take AI Ops. That's using artificial intelligence to proactively manage IT operations and prevent major system outages before they even happen. Or FinOps, maximizing business value in hybrid cloud environments. We're also seeing hyper-automation, which merges multiple tools to automate across the absolute broadest possible set of business workflows. And then there's cognitive automation, which literally structures unstructured data, doing all the heavy lifting of document redaction and synthesis at lightning speeds.
But here's the thing, absolutely none of those enterprise applications work without the underlying engines powering them. Intelligent automation relies entirely on some seriously advanced AI fields. Machine learning allows systems to learn from data and improve their accuracy over time without human help. Computer vision lets systems derive meaningful information from visual inputs, and natural language processing enables these digital assistants to recognize, understand, and generate human text and speech. These are essentially the brains behind the digital brawn.
Section 4. The automation paradox. The human element.
So we've talked a lot about how amazing this tech is, right? But highly efficient systems actually yield some incredibly counterintuitive consequences for us. Listen to this quote for a second. The more efficient the automated system, the more crucial the human contribution of the operators. This incredible insight comes from a cognitive psychologist named Lizanne Bainbridge way back in her seminal 1983 paper. This concept is actually known as the paradox of automation, and it completely flips how we usually think about machines replacing humans.
Let's break down exactly why this paradox exists. On one side, the automated system gets highly efficient, right? It requires less and less day-to-day human input to run. On the flip side, the human operator's involvement becomes much, much rarer. But, and this is absolutely crucial, when the system inevitably encounters an error that it can't fix on its own, human intervention becomes infinitely more critical. A really tragic illustration of this was Air France Flight 447, where a sudden failure of the automation put the pilots into a manual situation they were completely unprepared for simply because the system had been doing the flying for so long.
And, well, that brings us to the reality check. We kind of need to ground the hype a bit, because despite the incredible advances in AI, automation still faces very real limitations today. I mean, first off, there are incredibly high initial capital costs to set up these systems. Advanced robotics still struggle with really basic real-world physical issues, like battery life bottlenecks. A lot of these things only run for 2 to 4 hours per charge. Plus, they have a severe vulnerability to unpredictable human-made obstructions. Furthermore, machines still completely lack the ability to perform high-level subjective assessments or do genuine strategic planning, so no, the human mind is far from obsolete.
Section 5. Society, Jobs, and You. Navigating the Future.
This brings us to the real climax of our explainer, scaling from massive global data right down to you and your career. Let's look at the numbers that sparked massive global anxiety a few years ago. In 2013, researchers Frey and Osborne from the Oxford Martin School published a totally startling estimate. 47% of all U.S. jobs were at high risk of computerization and automation. Let that sink in. Almost half the workforce. When this data dropped, it literally sent shockwaves through the media and the general public.
But wait a second, just 9%? Yeah, that is the estimate from the OECD, the Organization for Economic Cooperation and Development. Looking across 21 different countries, they found that only 9% of jobs are entirely automatable. So our sources show a massive, massive debate going on here. Why the huge difference? Well, it turns out because a lot of automation doesn't replace an entire job. It usually just automates portions of the tasks within that job. The data is incredibly nuanced.
However, the economic impact, that is absolutely real, and it usually shows up as income polarization. Technological advances tend to drive up the wages and the demand for highly skilled labor, the people who design, manage, and leverage these advanced systems. But at the exact same time, it drives down the demand and the wages for middle-wage, routine labor. It effectively hollows out the middle class, creating a pretty heavily widening gap in the economy.
And history shows us that society reacts strongly to this kind of economic disruption. We're looking objectively at the data from our sources here, which track this behavior over time. During the Industrial Revolution, Luddite textile workers physically destroyed weaving machines. Fast forward to recently in Arizona, residents were actually slashing tires and throwing rocks at self-driving cars. Economists also note that job anxiety related to automation consistently fuels the resurgence of nationalist and populist politics globally, and it sparks super intense debates over union protections and national safety nets. Regardless of your personal politics, the data clearly shows that technological unemployment anxiety drives deep socioeconomic shifts.
So how do you actually protect yourself in this kind of landscape? Well, economists Eric Brynjolfsson and Andrew McAfee divide the workforce into two main categories. They say ordinary skills, which are routine, repeatable tasks, are being acquired by computers and robots at an extraordinary rate. Honestly, if you only have ordinary skills right now, it is a tough time. Conversely, special skills, things like creativity, complex problem-solving, strategic thinking, those are what allow humans to actively use technology to create and capture value. Simply put, there has never been a better time to have special skills.
Which basically leaves us with one final vital thought. Look, the machines are already here. They have been since the water clocks of ancient Egypt, and they are only getting smarter. The system is changing, the whole economy is shifting, and the definition of a valuable worker is literally being rewritten as we speak. So I'll leave you with this. How are you adapting your skills for an automated future? Thank you so much for joining me on this explainer today. Keep learning, keep adapting, and I'll see you next time.